right? So every time it is reducing. Now let's do this. Yeah. So with this intuition, the first, of course, the first loop you have to run n times, because n times you need to compare pairwise do comparison. It happens n time. But for the second loop, you can reduce. How do you reduce? So n minus I minus 1. This is the expression which we can use for the inner loop. Now how does this help us? If you recall, first time I will be 0, right? First time I will be 0. So your inner loop will run from 0 to n minus 0 minus 1. N minus 0 minus 1 is nothing but n minus 1. So uh, so which is effectively 0 to n minus 2. That's all we want. Why? Because what you compare, 0 1 1 2 2 3 so on, n minus 2 and n minus 1, these are the pairwise elements that you're going to compare. So in the first iteration, all your inner loop needs to run is from 0 to n minus 2. So if we give in the range n minus I minus 1, when I is 0 in the first iteration, your inner loop will run from 0 to n minus 2 indices. That's all. Then it will pick the next indices as pairs and start comparison. So this is the whole idea. All right. So with this idea, now it's the logic part. How do you, when do you swap? In your regular bubble sort, if the values, if in the pair of values that you are comparing, if the value on the left is greater than value on the right, you just swap. But in this case, the condition changes. So if frequency, frequency map of which number you will pick, nums of j, correct? Nums of j will be your inner loop's current number. First, for example, it will be 0 in the first iteration. First one, it will be index 0 is greater than frequency map of nums of j plus 1. Why? Here we are running from, you are comparing 0 and 1. Next time j will be 1, so you will be comparing index 1 and index 2. Next you will be comparing index 2 and 3, so on. And when index n minus 2 comes here, range will, you see, range function, it will run from 0 to n minus 2, because the range top value is n minus 1 when I is 0. First iteration I'm speaking about, when I is 0, this will become range of n minus 1, meaning it will run from 0 to n minus 2. So when n minus 2 value comes, j takes n minus 2, what is going to happen? Nums of n minus 2 will be compared with nums of n minus 1, which is the last element. So effectively the last pair will also be compared, and hence you, so if the frequency of the number on the left hand side in your pairwise comparison is greater than the frequency of number on its right hand side, which is the pair, if you take the pair next index, then you're going to swap those two numbers, correct? Because you need to sort the yes, numbers that appear less frequently should come first. So this is the whole idea. And so there is a second clause. So if two numbers have the same frequency, their order in the original list should be preserved. Now there is another possibility. If this happens, then it needs to be swapped. That is one case. Or there is another possibility that, so we will write an or expression for that to indicate the other possibility. So this is one case when numbers get swapped. Or when does the numbers get swapped? If the both the frequency map of j, the current index and the immediate next index in the pair are equal. And when do you swap now? When do you swap now? What does it say? If the frequency, if two numbers have the same frequency, order in the original list should be preserved. In this case, when do you swap? If frequencies are same, but the index of the right hand side number in the original list is less than the index of the left hand side number in the original list. What does it mean? So here, let's suppose I have a list like this. So I'll show it here. Oh, your original list is something like this. So 1, 2, 4, 4, 2, 3, something like this. Now, when you compare 2 and 4, you see that their frequencies are equal. Your frequencies are equal, correct? So, but 2 appears before 4 in the original list, right? So, 2 should be taken first in your sorted frequency mapping list. That's what it means. So, when are you going to swap? Suppose if there was something like this. So you check the index of 2 in the original list and index of 4 in the original list. So you compare, right? If the index of 2 is less than index of 4, then you don't need to swap because 2 appears first in the original list, so 2 is retained. But if the index of 2 is higher than index of 4 in the original list, for example, something like this. Now 4 and 2 have same frequency, but 4 appears first in the original list, then you need to swap 2 and 4 if you are comparing 2 and 4. So it is for that condition. So we will see that part in the code level. So how do you get the index of a number in the list? So there is a built-in function called list.index. So list.index of whichever number you are checking on the left side. If the index of the left side number, all right, in the original list is greater than the index of the number on the right side of the pair, which you're comparing. So then also you need to swap. Just I'll reiterate here. You see, when are you going to swap? If the frequency of the number, if you take a pair of numbers, here we are doing always pairwise comparison, remember? If the frequency of the first number is greater than the frequency of the number to its right, then you're going to swap. That is clear. Or if they're both frequencies are same, frequency of your current number and the next number in the pair, they are same, but in the original list, the frequency of, sorry, the index of your current number in the pair which you are considering is higher than, greater than the index of your next number in the pair in the original list, then also you're going to swap, because what they have mentioned is if the frequencies are same, then their order in the original list should be preserved, whichever number comes first. So in this case, what happens? If the right in the pairwise number, if the right side number is appearing first in the list, original list, then also you should swap if their frequencies are equal. If their frequencies vary, there is no doubt. At the end of this iteration, what is going to happen? The number with the highest frequency is going to go and sit at the end of your list. This is what is going to happen. So simple. Then what you need to do, if these conditions are true, then it's about swapping. How do you swap in Python? So nums of swapping is a simple operation. Nums of j comma nums of j plus 1 is equal to nums of j plus 1 comma nums of j. This is a simple statement to swap two numbers, a comma b equal to b comma a. So a's value will be copied to b and b's value will be copied to a. So this is when you swap. So at the end of this, both the for loops, the outer and inner, your list will be sorted. All right, here based on the frequency, your original list. Then after this, you can return the nums list. So this is your function, sorting function. Right? The next thing is how to take the input. So there are two things mentioned. First, you need to take n. The first line of your input contains integer n, the number of elements in the list. So I can say int of input, that is your first number, which is going to be your first line in your input. It will indicate n, how many elements are there. The next element, the next line, what it says is, you see, second line contains n space separated integers which represents the list. So it could be something like this. Your second line will be 1, 2, 3. In fact, it will be randomized 3, 5, 1, 4, 2, something like this. Now, how do you take this as input? So let's see that. Let's see on that part. Okay. So now we will go through the logic again for the benefit of those who are a bit confused. I can see it in the chat. So n, now we need to process this. So what we will do is, first we will read this line as a string completely. So how can you read that line as a string? So you can just by calling input function. Let's take s is equal to input. So now what will my s be? So my s will be 3, 5, 1, 4 and 2. So this will be my, once I read the complete line of space separated numbers, which is how your input is given as input. So it is going to be like this, s equal to input, it's going to be a string. Now I need to get a list of numbers, convert this to a list of numbers, because I need to pass that list to frequency sort function, right? So how to convert this to the list? So there lies. So one thing, you have studied strings and we have seen it that there is a built-in function called split on the string, which is going to split the input and put each element in a list. Split the string and put each element in a list. So you can say, if you say s dot split. So if I say L equal to s dot split, by default split happens based on space as delimiter. So your list will be 3, 5, 1, 4, 2. This is how your list will be. Now there is still more work to be done, because we have separated out all the numbers, all the integers that your input space separated, well and good, but there is something more to be done where we need to convert this to integer. Right? How to convert this to integer? So there is a built-in function called map. I'm not sure if you've come across this in your regular sessions, but so yeah. So there is a built-in function called map. It takes two arguments. One is some function which you need to commonly apply on each element of the list. So map is used to apply a specified function on every element on the list. All right. Now what we are going to do, all you need to do is apply int function, this int transformation on each element to convert that to int. So to map, what we pass is, one is int, the function which you want to apply and on which list you want to apply. So on the list L you want to apply. So once you have this, you will get an output in the form of a map object. So we will convert that into list. So if you say list of map of int comma L, so this will give you a list something like this, 3, 5, 1, 4 and 2. So which will be what is needed, what is required for your original list to be passed. So now we will combine these operations into a single line, that's all. So what we will do is, so first your list is going to be L, or a nums list, you can say numbers list is going to be, first we will take input and then we will split. Correct? That's what I'm doing here. Input I'm storing into a variable called s, and then I'm applying split. So input dot split will split the input and store it in a list. Now we need to apply map transformation on this list. So I'll call map of, now this input dot split is a list, correct? It is nothing but L. So now we will use that. So I'll apply map on this list with int as my transformation, int function as my transformation, which will transform, which will convert each element of the original list, which are strings, into integers, and I convert that into finally a list. So if you just whatever I've shown here in splits, I put it in a single line to make it efficient, that's all. So this I will anyway comment it out for your reference how it came, but this will give you a list, and then you can directly now call your function frequency sort n comma nums, and it should give you the output. Let's see and sample input and output, right? So let's see. Let me run this. So it will ask for a two things now. One is the number of elements in your list. So it's taking time to initialize and run. So let's take a 6 element list, and the frequency and the elements are 4, 5, 6, 5, 4, 3, let's say, right? So now this is the final output where the elements are sorted based on the frequency. Clear? Of course, each element appears, how many times it is there in the original list, it appears, just that the output list size is same as your input size, but it is sorted based on frequency. Because you see, now here is the thing, 6 appears once in the list and 3 also appears once, so they should come first. But among 6 and 3, which should come first? Among 6 and 3, 6 should come first, because that is what is present in your original list first, as opposed to 3. So this is why we have written this logic here. So in the inner loop, the swapping happens if the frequency of the item, when you are comparing pairwise, right? Take two numbers pairs. The first left-hand side number's frequency is greater than the right-hand side's frequency. You are going to move, swap. Or if their frequency match, but left-hand side numbers index. So that's what nums dot index will give you. Dot index will give the index of the particular number. Index of nums of j. So index of nums of j will give you the index of this particular j is the in the pair, j is the first number, left-hand side number. That index it will give you with respect to the nums list. In the list, what is the index of your left-hand side number in the pair? And it will compare the what is the index of your right-hand side number in the pair. Nums of j plus 1 is, if you take a pairwise, the right-hand side will be your j plus 1 number. So both, when you compare, if the left-hand side's numbers index is greater than the right-hand side numbers index, then also you're going to swap. Because what is the rule? In the original list, whichever element appears first, whose index is lesser, that should come first. So then also we are going to swap. So these are the two conditions in which you are swapping, otherwise you retain. So at the end, what will happen? The most frequent element will go out towards the end of the list. All right, so took a good amount of time for this. So I hope I have explained the logic. So some people are just like asking, where did this n minus I minus 1 come from? So I think yeah, that's what I wrote on the notepad, if you remember. So when you compare, do I have it here? Yeah. So sorry about the ads. Where did that go? Yeah, just to reiterate, when you compare, right? First time, let's say there are 5 elements. So I don't even worry about numbers, E1, E2, E3, E4, E5. So I do a pairwise comparison. So 0, 1, 2, 3, 4 are its original indices. First time, what I'll do, I'll compare 0, 1, 1, 2, 2, 3, 3, 4. These are the 4 indices that I need to pick and then compare. Now at the end of first iteration, your last element is going to go and sit in index 4. So I don't need to touch that. Next time while doing pairwise comparison, I just need to compare 0, 1, 1, 2, 2, 3. So your number of indices, if you see the range, so it will be 0 to n minus 2 in the first iteration, 0 to n minus 3 in the second iteration, so 0 to n minus 4 in the third iteration, and so on. So to come arrive at this, what we have done is your I also varies in every iteration, right? So first time I will be equal to so first time I will be equal to 0. So if you give if you want to run your pairwise loop from 0 to n minus 2 inner loop, all you need to do is 0 to range of, so basically range function you need to call range of n minus I minus 1, which is effectively range of n minus 1. Range of n minus 1 will run from 0 to n minus 2. This is what you know. In when I becomes 1 in the second iteration, when I is 1, you need to run from 0 to n minus 2. This is what 0 to n minus 3. This is what you know. So what happens, uh, for to the range function, you passed n minus I minus 1, correct? So or n minus 1 minus I. So it will be like n minus 1 minus 1, nothing but range of n minus 2, correct? So it will be running from 0 to n minus 3, because range of n minus 2 means it will be 0 to n minus 3, correct? Range is 1 less than the end. So basically, through this particular statement, let me share it here. 0 in the inner loop, range n minus I minus 1, you are reducing the number of pairs that you are comparing in every iteration. In the first iteration, you need to compare all possible pairs starting from index 0 to n minus 2. But in the second iteration, when I becomes 1, you need to compare only those pairs of indices starting from 0 to n minus 3, like this. To reduce that, every time your pairwise comparison space, we use this n minus I minus 1 statement, so that your I, as I increases, the search pairwise search reduces, because you start accumulating your larger values towards the end, and they don't need not be touched. That's the idea. So you reduce your comparison space. All right. So yeah, I hope it is clear, this exercise. So yeah, wanted to do another problem, but I think we are running out of time. Let's try in tomorrow's tutorial we have anyway. With we'll see. So I hope the bubble sort idea is clear. It's all about pairwise comparison. And you remember, every iteration, the largest element goes and sits at the end of the list, and it won't be touched again. So the next time, when you compare pairwise elements, you just need to compare until last but one index. No need to touch the last index, because largest element is already sitting there. With that idea, we have built this. And in this case, it required specifically a frequency based sorting. So we maintained a dictionary frequency map, and it was comparison was not based on the numbers value, but based on its frequency. So which we took from the frequency dictionary. If two frequencies are equal, then we compared the index of those numbers in the original list. So whichever comes first, we put it first, and in the pairwise. So if suppose the left hand side's index is higher than the right side's index, so we put it swap. So swapping, this is the swapping operation, and at the end we return the collab link. I do have, I think I've shared. It's shared on your notes, I believe. Let me again anyway share it. Anyone can view basically, right? So I'll paste it in the chat box. There are a couple of questions which I can address maybe in the tomorrow's tutorials due to time constraint again. Can we optimize this using break? Possible. So there is a argument that if you have just the list, you can always deduce n from that. It is derivable because you know how many elements are there in the valid things. So yeah, we will discuss. But yeah, input format as per it is like this. So in the problem statement, so go with that input format. Follow that. That's what we. All right. Thank you for your session. Have your dinner, and you can come back for slot 2. Thank you.
Thank you, Shashank sir, for the session. Participants, we will meet after our dinner break after half an hour for the second slot of this session. So thank you very much, sir.
Thank you so much. Yeah.